Hello guys, and welcome back to part 6, I believe, of our mole shooter game tutorial. My name's Krillin. Well, in fact it's not Krillin, but my YouTube name's Krillin. And today we are going to be covering the final part of our mole shooter tutorial. So today hopefully we will be able to squeeze in the mole hopping routines, the splat routine where we throw some blood over the mole as we make contact with him with our crosshairs and shoot him between the eyes, and also the scoreboard. So without further ado, let's get on with the shooting. So first things first, we want to get the mole animated on the screen. To do that, we will use our update mole method, which I have prepared earlier, obviously to save typing. Now essentially this is just a very simple function which we call, or method that we call, and we called it update mole. Call it what you like, but I've chosen update mole. And in here you can see that we're actually calling the update method, which is inside our mole object which we created in the previous tutorial, and we're passing into that an X and a Y. Now obviously this does not look like X and this does not look like Y, but essentially this is producing a random number between the maximum width of the mole, i.e. that's the minimum. Okay, so random.next, the minimum value, X value will be the first parameter that it takes, and then the maximum X value will be the second parameter that it takes. Okay, so here we're essentially saying is the minimum X value that we're passing into our update routine is the is not to go below the mole's width. Okay, so it can go anywhere between the mole width and the width of the viewport that the game is being shown through, minus the width of the mole. Okay, so essentially what this does is it keeps the mole on the screen. Okay, so having a minimum value equal to the maximum width of the mole will ensure that the mole does not disappear off the left hand side of the view, and then having a maximum X value of the viewport width minus the width of the mole will ensure that the mole does not disappear off the right hand side of the screen. And the same again down here for the Y value. Okay, so we set the Y value to the height of our viewport divided by 2, so that's essentially half the viewport. So this will then keep the mole below the second half of our screen, and this dot height minus resource dot mole dot height times 2. Again, that will essentially keep the mole from dropping off the bottom of the screen and hence staying on our field and not disappearing out of our field of view. That is as simple as this gets. So the next thing we need to do obviously is to call this and then refresh the screen. Okay, so to do that we obviously need to call the update mole routine, and we'll do that with inside our game loop here, our timer game loop. We'll terminate that with a semicolon, of course. And then obviously we've updated the X and the Y, but the screen does not know at this time to redraw itself, so we have to use this dot refresh statement, and then that will force the screen to redraw itself. Okay, now the game loop I believe we set to 100 milliseconds, so if we select our timer object here and go over to the properties and look, you'll see that we've set it to 100 milliseconds. So that essentially means that when we run the game, the mole will be updated every 100 milliseconds. And to prove that, we will run the game, click start, and as you can see he's hopping around there pretty damn fast, and we have no chance in hell of hitting him, so we need to slow him down a little bit. So let's quit the application and have a think about how we can slow this chap down. So clearly we can obviously go and increase the game loop increment value or interval value to 500 or 1000. This is the interval value is milliseconds, so at the moment we're hopping around every 100 milliseconds. So I reckon about 500 milliseconds or a second is a reasonable time frame for this guy to be hopping around in. So we can set this value to 500, and that will have the desired effect of slowing the guy down, the mole. But what it means is that any other image that we send to the screen will also be displayed for 500 milliseconds before it's refreshed. which isn't essentially what we're after, because obviously when the mole's head explodes as our armored piercing shell goes through it, we don't want the blood splat to be on the screen for half a second. We want it to be there for something like 100 milliseconds or 200 milliseconds. So we want better control over the screen frame rate. Okay, so I think 1 frame refresh every 100 milliseconds for now will be ample. That means then that we can throw objects onto the screen for a minimum of 100 milliseconds and then release them. So let's go back to the form code, and inside our game loop we essentially want a counter of some description to count up to 5 before it updates the mole, and not 5 because obviously we're going through this loop every 100 milliseconds. 5 times 100 milliseconds is 500 milliseconds, which is half a second. Half a second is our desired interval. So let's create a global, and let's call this game frame. Let's set it to default value of 0 at the moment. Let's put an underscore inside of that just to show that it's a internal property. And then down inside our game method here, inside our timer game loop method, we need to increment our game frame. In fact, actually, let's not increment it at the moment. Let's check to see if our game frame value, Control C, is equal to 5. If game frame value is equal to 5, or actually it's greater than or equal to, it's probably the best thing to do, just in case we overshoot 5, which is unlikely, but you never know. Braces. Okay, so when we hit the game loop, we need to obviously start the game frame counting, or check the game frame hasn't got up to 5. If it has, obviously update the mole, and then drop out of that, and then update the game frame by incrementing it by a value of 1. So game frame plus plus, if you didn't already know, it will increment the this property by 1, and then it will keep incrementing by 1 as it goes through the game loop until at such a point that it hits 5, and then it will go into our update mole and update the mole. At which point we need to reset the game frame back to 0. Okay, so that essentially resets the game frame, ensuring that we re-enter the game frame if statement and update our mole. Hopefully that's that. So now when we run the game and start it, our mole should be hopping around every half a second. As you can see, he clearly is, and we stand much better chance now of hitting him than we did before. Well, we do if we're a good shot, which I clearly am not. So let's stop that. And let's start to think about the blood splat, which we're going to throw on the screen after we've managed to hit the mole, so that we can see we've got a clear hit indicated. So first things first, we need to set a Boolean flag. This is going to be a splat flag. Bool splat. We'll set it to false. Now, the whole idea behind the splat flag is to indicate to us that when splat is false, the blood splat does not display on the screen, and when splat is true, then the blood splat is displaying on the screen. We will set splat to true when we hit the mole in our mouse click routine down here. In the else down here, what we're going to do is we're going to check that whether we've actually hit the the mole even, and if we have, then what we'll do is we'll set the splat to true, so that when we come back up to the game loop, we can check the status of the splat flag, and if it's true, we know then at that time we need to start the splat counter, and then we will count 3 frames. That's 300 milliseconds, or 3 times 100 milliseconds, and then at that point we will then reset the flag back to false, reset the splat counter back to 0. So in here we need to do an if parentheses splat, i.e. if splat is true, then execute the following block of code. And that's not supposed to be solat, that's supposed to be splat. And then in here we'll say if parentheses splat time is greater than or equal to 3, i.e. 300 milliseconds, then we've obviously looped through the game 3 frames, and thus at this point we then want to start resetting the flag back to 0. So in here we will put splat equals false, so that will reset our display flag, or our splat display flag, back to false again. So it's telling the system now not to display the splat. We want to set our splat time back to 0. So so that it resets, and we want to update our mole. Update mole. Okay, save that before I move any further. Oh, it's always wise to save regularly. Oh yes, and let's not forget to update our splat timer. So underscore splat time plus plus. So that will increment that each time it goes through the splat loop. Okay, so the next thing to do is to update the onPaint method to take care of the drawing of our paint splat. So we want to do if splat equals true, then draw our splat, else draw our mole graphic. Okay, so get our score frame, draw, sign, no, oh no, where's our mole gone? Oh, here we go, mole.draw image. Take him out and place him in here. Of course, we don't want to put the sign and the score draw images inside this statement, because we want to keep the sign and score frame on the screen all the time. It's only going to be the mole and the splat that's going to be updating. We need to obviously move the declaration for the device context above the if statement, so that we can successfully pass the device context into our draw routines. And then we want to call the splat dot draw image and pass in the device context. That will then obviously go and draw the image on the screen. Save again. And the next thing to do obviously is to handle the mouse click event when we are over the mole, and you can see here I have already typed the code in just to speed things along a little bit. So essentially what we're doing here, checking to see whether we've obviously hit the start, stop, pause or exit on our sign. If not, we fall out and then we go and we check to see if our mole's been hit. Okay, so we've clicked the mouse on the mole, hopefully, and the X and the Y coordinates are passed into our mole object .hit routine, which we actually created in an earlier tutorial. If you haven't seen that, yet, then go back and read that. The construction of the mole object, and you will see how we handle the hit method. Then inside here we obviously want to tell the system that splat is now true, so display splat on the screen, and then we need to handle the coordinates of the splat bitmap. Okay, so if you was to display the bitmap where the upper left and top were the same as the mole upper left and top, then the splat would be slightly right and down of the because the splat image is bigger than the mole image, so it will be offset to the mole image. So we need to slide the splat image slightly to the left and slightly up so that it looks more central to the mole when she is drawn. So to do that, we get the left hand coordinate of the mole image, and then from that we will shift left by the splat width divided by 3. Okay, so it's about 33% overlap to the left of the mole image, and we'll do that same again for the top. We will get the top of the splat will be positioned at the top of the mole, and then the height of the splat divided by 3 up above the mole. Okay, so hopefully the graphic will appear more central to the mole. If you don't know what I'm talking about, then just leave a comment below and I'll try and explain it to you a bit clearer. But essentially, we just want to get the blood splat image center to the mole image. Okay, and you just play about with these values here until you've done that. You can obviously get a calculator out and work it out to the nearest pixel, but you know, I can't be asked. This is going to be close enough. Again, save it. Okay, so time to run her up and see what occurs. Start. Okay. So I think it's going a little too fast, and what's happening is I'm getting a persistence of vision, so it looks as though I'm hitting the mole, when in fact I think the mole's actually just begun to hop as I fired, and thus I'm outside the hit region on the mole. Because as you can see, every so often I'm actually getting a hit and then I'm missing a hit. So or it looks like I'm missing a hit. So let's stop that for a minute, and then let's crank the speed down a little bit just to prove my theory. So if we set that from 5 to 8, for example, so that's 800 milliseconds, so it's just short of a second, and then we'll rerun and see what occurs. Let's just start. Okay, so you can see that slowed him down now, and he's actually on the screen a little longer, so there we go. So we can hit him slightly more easier. So it's either persistence of vision, i.e. he's moved and just at the moment that you've clicked, and therefore it's not actually registered, or you may be getting a slight time overlap because we are registering the frame every 100 milliseconds. So it might be that we are clicking and then updating the mole position just shy of clicking it, and thus the when we do the mole check down here, the hit check, we're actually outside of the region. So slowing it down seems to have done the trick, but at some point in the future we can probably return to that and try to synchronize the game a little bit better. For now though, for the demonstration of this game, it is good enough, I feel. Next thing to do is to start looking at the scoring system. So where are we? Game loop. Actually, what I want to do is just tidy these up. So I'm going to create 2 constants at that moment. Constants. So we're going to create 2 new const int, and we're going to say frame. Let's call it frame num equals 8 semicolon and const. So these are constants, i.e. we're not going to change these within the application, they're fixed values. We can change them obviously in the IDE, but not during the game. So we'll call this one splat num equals 3. Then we can obviously copy these down here and replace the hard-coded values with frame num and splat num. There we go. Save that. So as far as scoring goes, we want to track our hits, misses, total shots and average hits. So we will place some pre-typed code in here, which are our hit, misses, total shots and average hits property declarations. So we want to obviously track our hits so we know how many hits we've had, and we'll keep an eye on the misses, and from that we can calculate the total shots, and from that we can obviously calculate the average hits. And of course we need to display the scores on the screen, so to do that we will copy some text from our prototype application and paste that down here. As you can see why it will take some time to type all this in, and it obviously speeds things up pasting it in. We covered this in a or the text forming at least, in a previous part. I think it was part 2 with regards to debugging the screen, where we put the X and the Y mouse coordinates on the screen. We used exactly the same process. We created some flags here, some text flags which told the text how to align itself. We created a font object which told the text how to look, size wise, style wise, etc. And then each line here will put a new line of text on the screen, one being the total shots, one being the hits, misses and average hits. Okay, so if we run this, you'll see now that we have some text on the screen up here at the top left inside our scoreboard. Okay, so we obviously need to update this now. We will do that obviously during the mouse click routine. We will detect obviously here that we've actually made a hit, and if we've made contact, then obviously we will increment the hit counter. So this will be hits plus plus, and obviously if we've missed, then we will have miss as plus plus, and then the total hits is obviously going to be our hits plus our misses. Okay, let's just check that, make sure everything's running as expected. Start the game, get a hit. Okay, so okay, so everything's working okay except for the total number of shots. It appears to be randomly incrementing itself by 2 or 1. So for example, we have 30, 31, 32, 34, 35, 36, 37, 38, 41. So every so often it's going up by a factor of 2. So I'm not quite sure what's going on there. Let's have a look. Okay, I believe it is this line here. We're obviously dropping out of the hits, so we're actually incrementing hits, and then we're incrementing misses. But of course, misses is being incremented, even though hits is being incremented. So we're getting 1 plus 1, 2. So that's the problem. So what we do here, stick an else, and as usual, I can't spell to save my life. Got the curly braces, and then we'll put the misses line inside of that brace there. Let's tidy that up a little bit. Save her. Dun, dun, dun. Start again and have another shifties. Start. Okay, so as you can see now, that's keeping the total tally correct. 7 plus 3 is 10. Okay, so to calculate the average score, we need to obviously define the average. Hits equals hits over total shots. Hello. And because we're talking about a double here, average hits obviously, remember when we declared it above is a double, and you can see here in the IntelliSense it's confirmed to be a double. We need to typecast these into a double. So to typecast something into a double, you obviously prefix it with the type that you wish to typecast to. So double and a double, and then to get the percentage, we will then divide this by 1. Sorry, divide, what am I talking about? Multiply this by 100, period 0, then terminate that with a semicolon, start her up and see what is occurring. Start. Right. So that's a shot and a miss. So the average score is 0. And again, 2 shots and a miss. That's a hit. So we've got 1 and 3 now, so that's 33%. Keep going. Now we've got 2 and 4, so that's 50%. So the average is working fine. Stop that. So one thing we can do, if we so wished, would be to add a player skill level to the game. So for example, if your average hit rate percentage was, for example, I don't know, 100%, and you'd fired off 100 shots, you're obviously pretty good at this. We can then change the game frame rate from, say, 800 milliseconds to 500 milliseconds or 300 milliseconds, essentially speeding the game up. And then obviously that's going to make it harder. Because of that, your average frame rate will come down, and at some point you will get below a certain threshold, and then you can reset your so-called elite status back to normal status. So you can obviously wire this up to a player skill level mechanism, but I'm going to leave that, I think, for now, and maybe add it at another time, because the video has obviously gone on now for quite some time, and yeah, we want to save some bits and pieces for future updates. So I hope you guys enjoyed this video series, at least up to this point. If you have any feedback or any positive or negative comments, then feel free to leave them below. It'll be nice to hear from you guys, especially if you have some tips or advice on how to improve the game. If not for me, certainly for the rest of the community. And yeah, I've certainly enjoyed it. It's taken a little while, I know, and hopefully at some point in the future we will be popping up some more tutorials for you, and it's been a pleasure taking you on this journey with myself. So until then, have a great time. Remember to subscribe and like below, please, and I will see you at some point in the future. So happy coding, guys, and happy gaming. Bye for now.